The goal of this video is to be able to teach you how to solve a one-step inequality. So obviously you've been talking about inequalities in that they use the greater than and less than signs. Okay, so greater than, less than, sometimes they even have an equal sign underneath. Okay, just as a refresher, inverse operations, remember, is what you're using to solve equations or inequalities. So if you remember, adding and subtracting, those are like inverse operations. They kind of undo each other. Okay, same with multiplying and dividing. Okay, they undo each other. They're opposite operations or using the inverse operation. So when you go to solve equations or inequalities, you're using those inverses. Looking down here, as we've solved equations like x plus 2 is equal to 7. So as you go to solve this, keeping it balanced, you are subtracting 2 on both sides. Adding 2 and subtracting 2, again, are inverse operations, so they cancel each other. So the only solution to x is that x could be 5. And again, we always prove that by substituting 5 back in for x. Okay, and the only solution to keep this balanced would be 5 plus 2 equaling 7, so the left and right side of the equation are balanced. The major difference with an inequality is that inequalities have many solutions. So in inequality, you will not see an equal sign being used. That's why we use an, an inequality sign. So if we were to change that x plus 2, let's say, has to be something greater than 7, now, there are a lot of possible solutions for what x could be. So I'm going to show you over here using your worksheet how to actually solve these, but just giving you a quick preview. If you do the same thing that you would normally do with an equation, adding 2 and taking away 2 will cancel. So x, you're going to just simply use this sign and rewrite it down below. 7 minus 2 is 5. Now our solution is that x has to be something greater than 5. So that means x could be 6 or 7 or 8 or even some decimals or fractions, because we want this left side to be greater than 7. Okay, so let's take a look at your worksheet and walk through some examples together. In the first problem, you're looking for x plus 5 has to be something less than 6. So again, to solve this, keeping this balanced, I'm going to try to write here as small as I can so you can see this. You're gonna do, sorry, not minus 6. You're going to use, again, the number that's with your variable, okay, to be able to isolate your variable. So on this side of the equation, you're going to show, sorry, I'm having trouble with my pen here. So to keep this equation balanced, just like you would solve an equation, rather than adding 5 on both sides, you're going to subtract 5 and subtract 5 on both sides of the inequality. Adding 5 and taking away 5 will cancel, so x is less than, I'm just bringing down my sign, 6 minus 5 is 1. So x can be anything less than 1. That means x can be 0. X can be a negative number. Okay, let's try the second one. Second one is using multiplying, because 9 right beside a variable means to multiply. So to use the inverse, you're going to divide by 9 and divide by 9. 9 dividing by 9 cancels to 1. So you're left with x. Just bring down the inequality sign. Greater than or equal to 3 over 9, which could simplify just to a third. Okay, so in this case, x has to be some type of fraction. So x can be anything bigger than a third or equal to a third. So in this example, it could be 1/3, or it can be anything bigger. Maybe it could be 1 whole. Okay, so actually it doesn't have to be a fraction, but it could be a fraction in this example. Okay, let's look at the second one. I'm sorry, the third one. This is using subtraction. So you would add 2 on both sides. Negative 2, adding 2 puts you at 0 on the number line, so that cancels. So x bring down your sign, is greater than 6. X can't be 6. It has to be something greater than 6. So it might be 6.5, 7, 8, okay, to show that that left side of the equation is something bigger than 4. Okay, moving down to number 4. This is using division. So again, the inverse would be to multiply. So you're going to do times 9 and times 9 on both sides of the inequality. Dividing by 9 and multiplying by 9 cancel each other out, okay, because they kind of undo each other because they're inverses. Bring down your sign. 1 times 9 is 9. So this is showing you x can be equal to 9, because if you substitute that back in, 9 divided by 9 would give you 1, or x can be anything less than 9. Okay, trying that example number 5 is using adding. So you would subtract 10 on both sides using that inverse operation. This is going to cancel to 0. So x is anything greater than 7. So x can be 7.5, 8, 8.2, okay, anything larger than 7. So when you substitute something larger than 7 back in for x, that left side has to be greater than 17. So that's why 7 can't work. It has to be something bigger than that. Question 6 is using multiplication. So you're going to divide on both sides using the inverse. Okay, so I'm just trying to show a fraction bar there. 8 divided by 8 is 1. So that cancels to just 1x. Bring down your operation, or your inequality sign. And then 6 over 8, that could simplify, or you could just leave it 6 over 8. But if you divide both of those by 2, you would end up with 3/4. So x has to be something less than 3/4. All right, I want you to try 7 through 12. Just use the inverse operation every time you're solving this the same way you would have solved our one-step equations. Okay, then just go ahead and play this back and check your answers. Okay, checking these answers. Adding 10 to both sides, this will cancel, so x is anything greater than or equal to 12. In number 8, you should be multiplying by 4 on both sides, so x is anything less than 20. Question 9, subtracting 11 on both sides, that will cancel, so x is less than or equal to, oh, I'm sorry, you're subtracting here. I almost just added. Subtracting on both sides, you would just be left with 5. Okay, down to number 10, divide by 9, divide by 9. When you divide by 9, you get 1, 9 divided by 9. So you're left with x is greater than 12 divided by 9. Well, 9 goes into 12 one time, and you would have 3 left, and you'd keep your denominator, or you could say that's the same thing as 1 1/3. Adding 15 to both sides, that will cancel to 0. So x is less than or equal to 16. And last one, multiplying by 3, dividing by 3, multiplying by 3 will cancel out. So x is greater than or equal to 21. Okay, hopefully you did pretty well with those. If you want to flip your paper to the back, we're going to go over how to graph these possible solutions. On the back of your paper here, we're looking at how to graph the possible solutions. So that is your objective, to be able to correctly graph them. There's 2 things you need to know. In order to include the value, okay, so you're going to see symbols like less than and equal to or greater than and equal to. This equal to part is what's showing you that you do want to include that value of your possible solution for your variable. So in order to show that on a graph, you are going to use what we just call a closed dot. Okay, the closed dot is showing you're including that number. If you are looking down here and you're trying to exclude the value, you're going to see inequality signs that are just something less than or something greater than. Okay, it can't be equal to the value, so you're not including it, you're excluding it. And in order to show that, you're going to use what we just call like an open dot. So in looking at your examples over here in the first problem, first thing you want to do is go ahead and solve, which we just practiced. So you would add 2 to both sides of the inequality. -2 and +2 cancel to 0, so you're left just with x, bring down your inequality sign, is greater than 6. Now notice, x being greater than 6, I'm just using one of these two symbols, so I don't want to include the 6. Okay, so I'm going to use an open dot on 6. So you find 6 on the number line, use an open dot. X can be anything greater than 6. Shading to the right would include all the numbers that would be greater than 6. Okay, and number 2, x dividing by 3. So you are going to multiply by 3 on both sides of the inequality. Dividing by 3 and multiplying by 3 are inverses, so they will cancel. So x is anything less than or equal to 7 times 3, which is 21. Now to graph this solution, this time I do have an equal sign. That means it can be 21. Now I am including the value. So I'm going to use a closed dot in this example. So I find 21 on the number line. I'm going to shade in a dot on 21, and x is supposed to be anything less than or equal to that. So less than would mean shading to the left. So I'm showing all of these values could be possible solutions for x. It could be 21 or anything less than 21. In number 3, it's using multiplying, so you're going to divide on both sides to cancel 6 divided by 6 so that you're isolating your variable. So x is something less than 30 divided by 6, which is 5. So on the number line, now I do not want to include the 5. X has to be something less than 5. So that means I'm using an open dot on 5. X is anything less than that. So it can't be 5, but it could be 4.8. Okay, it can be decimals and fractions, anything lower than 5. Okay, solving number 4, you would subtract 9 on both sides. That's going to cancel, so you isolate your variable. X is greater than or equal to 11 minus 9, which is 2. So to graph these possible solutions, I find 2 on the number line. I do have an equal sign, so that means it can be 2. So I'm going to shade that in. And x can be anything greater than that as well. So I'm also going to shade everything to the right of this. So it can be 2 or anything more. Okay, you go ahead and try the last 4 problems here and then go ahead and check with the video to be sure you did them correctly. Okay, checking the last 4 with me quickly. You should have gotten a solution of x being greater than or equal to 20. So that means I can include 20, closed dot, or anything greater, you should be shading to the right. Number 6, x is less than or equal to 7. So I can include 7 because of the equal sign. X is anything less than 7. Number 7, x is less than 9. So I need an open dot because I cannot include 9. X is anything less than 9. And x is anything greater or equal to 8. That means I can include 8, so I want to close dot on 8. X is something greater or equal to. Okay, so 2 things to check. Did you use the correct type of dot, open or closed? And then did you also correctly shade left or right depending on the greater than or less than? So in summarizing what you should have learned from this video, you have 4 basic inequality signs as you see written here. These 2, again, will tell you that a number could include that value. So if it can include it, again, because you see these equal signs, if it can include it, that's when you want the closed dot to show you're including that value. Okay, otherwise you have the other 2 symbols. This does not include the value. Okay, and because you don't want to include it, you would use an open dot on your graph. Okay, so make sure you're understanding and being able to apply these to some real world problems that you'll be able to look at next. Okay, thank you guys.